I have gotten a couple questions because on the calculating the pH worksheet, there is a question asking you to calculate what the concentration is if you are given the pH. So here is a short video explaining how to do that and explaining how it works. Now, I do not know how many of you have had logs in math, how many of you have been taught, but this is kind of mathematically the way that it works and where the equation ends up. So we start off with our basic pH equation of pH equals the negative log of your H plus or your OH minus concentration. Okay, so now I have just changed that to CO and C for concentration. Okay, so we can rearrange this equation and so that we're solving for concentration rather than solving for pH. And this is how it works. So first of all, I have my negative right here on my log. So I'm going to multiply both sides by a -1 so I can get rid of this negative on the log. So once I do that, see here I've multiplied this side and this side by -1. That, of course, cancels out those negatives on the right side of the equal sign. And that makes your pH is now a negative number. Okay. And that leaves us with the log of the concentration on the right side. Now, in order to get concentration by itself, we need to divide by the log. Now, some of you may notice that I've changed this to log base 10. Whenever we see log, it's understood that it's log base 10 unless there is another number written right there. If you've had logs, you'll know that sometimes there are things you have to calculate log base 2, sometimes log base 3, log base any number. But if it just says log, it is understood to be log base 10. So I'm going to divide both sides of my equation by log base 10, which then cancels these logs out on the right-hand side. And when I divide by a log base 10, kind of like when, a similarity, when you divide by a fraction, remember how the denominator is moved up and becomes part of your numerator in the fraction. This base 10 is brought up to the numerator. Let me see if I can get my arrow to stay. Nope. There we go. That's close enough. There. And this now becomes, your coefficient, and the pH here becomes the exponent of whatever your base number is. So in this case, it's 10. So you've got log base 10. When you divide this by log base 10, you end up with 10 to the exponent of your negative pH number. So whatever your pH is, you make that negative, make it the exponent for 10, and that will give you your concentration. So for example, let's say I have a pH equals 4.2. That is what you're given. What? This is not working. There we go. Okay, so if this is my pH, 4.2, how can I find my hydrogen ion concentration from that? All I do is take the pH. I take the number 10. I make the pH the negative exponent of that 10. And when I make that, finalize that calculation, that is when I get my concentration. And that is, let's see, so 10 raised to the power of a negative 4.2, which my calculator's not wanting to do. Okay. 10 oh, and it's not wanting to do it. So sorry. There we go. Have to remember how to use this calculator. And the answer I get is 6.30957345 times 10 to the negative fifth. Okay, now if you realize that this exponent right here, if you use the estimating, this exponent works with what our pH number is, because our pH number for this should be between 4 and 5, right? Oh, and I apologize, something I forgot to teach you guys when it comes to estimating. If your concentration is exactly 1.0 times 10 to an exponent, let's say -7, then the pH of that concentration is the absolute value of the exponent, but only if the coefficient here for the concentration equals 1, exactly 1. Then your pH will be the coefficient, the absolute value of the coefficient. If your coefficient here is anything greater than 1, that's when you have your range of, like for this, if this were 1.2, then your range would be 6 to 7. Okay. I apologize about that. I forgot to put that into the other video. I will regrade the quiz accordingly. Okay. So I hope this helps.